Hey guys, welcome back to another video. This time we'll be going over current electricity and DC circuits and doing some example problems. So an important law in electricity and DC circuits is Ohm's law, which basically connects current, voltage, and resistance. Current is the rate at which charge flows passes a given point in a circuit, which is measured in amps. Voltage is the potential difference between 2 points, and it's measured in volts. Resistance is the opposition to current flow, and it's measured in ohms. And Ohm's law is basically voltage equals current times resistance, and it can also be rearranged in different ways to solve for different variables in a problem. Imagine you had a blocked off river. At the top of the river, the water would have a lot of potential energy, and in circuits, that would be equal to the voltage. Now, if you remove the barrier and the water begins to flow down the river, the amount of water that passes any given point at given second would be the current. And if the river gets narrower, the water flowing past would decrease, and that would be resistance. So you can see that through the equation also. So we can manipulate Ohm's law, and we get current equals voltage over resistance. So as resistance increases, the current would decrease. Kirchhoff's junction rule states that at any junction in an electrical circuit, the sum of the currents flowing into the junction is equal to the sum of the currents flowing out of that junction. So if 3 amps flow into a junction, then 3 amps should flow out of the junction. As you can see in the diagram here, 1 amp plus 2 amp would be equal to 3 amps that are flowing. Kirchhoff's loop rule states that the total sum of all of the voltage in a circuit has to be equal to 0. So you can write that as the summation of the change in voltage has to be equal to 0. So if we had a circuit here with two resistors, R1 and R2, and a battery, and the battery has a total voltage of this, and there is a drop of V1 over R1, and there's a voltage drop of V2 over the second resistor, and we want to find the voltage drop of V2, what that's equal to in terms of V1 and the total voltage. We can use Kirchhoff's loop rule. So we can say that the total voltage minus V1 plus V2 should be equal to 0. And then we can just solve for V2 from there. And we get V2 is equal to the total voltage minus V1. Electric power is the rate per unit time at which electrical energy is transferred by an electric circuit, and it's measured in watts. And the equation can be written as power equals voltage times current, and voltage squared over resistance, and current squared times the resistance. So there are two types of circuits, series circuits and parallel circuits. So the first one, series circuit, is a circuit where all the resistors are arranged in a line and the current can only take one path. And those are on the left, those are the rules for a series circuit. So this would be an example of a series circuit with one resistor where the current can only take one path. And now let's say the battery is 5 volts and the resistor is 3 ohms, and we want to find the current through here, through I2. So I2, we can use Ohm's law, V equals IR, and then we just solve for I by dividing V over R, and we would get I equals 5/3. I2 equals 5/3. Now if we wanted to find I1, we know that in a series circuit, all the currents are equal to each other, so I1 would be equal to I2. So I1 would be equal to 5 over 3 amps as well. So the other type of circuit is a parallel circuit, which is a circuit where the current has 2 or more paths to flow. And on the left, those are the rules for a parallel circuit. So this would be an example of a parallel circuit. with two resistors, and the current has two paths to flow. Now let's say the battery on this one would also be 5 amps. I mean 5 volts, and there's two places that we're measuring the current. And I'll say the first resistor is 3 ohms and the second resistor is 5 ohms. And now we want to find R1. So in a parallel circuit, 1 over the R total is equal to 1 over R1 plus 1 over R2. So we put 1 over RT is equal to 1 over 3 ohms plus 1 over 5 ohms. And we get 8 over 15 equals 1 over RT. So the total resistance would just be 15 over 8 ohms. Now if we want to find current 1 and current 2, well, we know from Ohm's law that I equals V over R, and the V is the same throughout. So for I1, we could just do 5 volts divided by the first resistor, which is 3 ohms. You get I1 is 5 over 3 amps. For I2, we would do the same thing, except we use R2, which is 5 ohms. So we get I2 equals 1 amp. So this is a quick example problem. A motor is a device that, when connected to a battery, converts electrical energy into mechanical energy. The motor shown above is used to lift a block of mass m at constant speed from the ground to a height h above the ground in a time interval delta t. The motor has constant resistance and is connected in series with the resistors of resistance R1 in a battery. Mechanical power, the rate at which mechanical work is done on the block, increases if the potential difference, or voltage drop, between the two terminals of the motor increases. Determine an expression for the mechanical powers in terms of mass, height, delta t, and physical constants as appropriate. So we know the equation for power is work over time, and the equation for work is force times distance. Now we know the force applied, which is just mass times gravity, and the distance that this is done over is height h. So d equals height h, and we plug that into the power equation, so we get power equals mass times gravity times height over delta t. Now, without m or h being changed, the time interval delta t can be decreased by adding one resistor of resistance R2, where R2 is greater than R1, to the circuit shown above. How should the resistors of resistance R2 be added to the circuit to decrease delta t? Well, it should be added in parallel with R1, because in the entire due to not Ohm's law, Kirchhoff's loop rule, if the total voltage used by the two resistors decreases, the power going to the motor should increase. So we want to decrease the voltage used by voltage drop over the two resistors. So if we place R2 in parallel with R1, more power would go to the motor because less power would go through the parallel circuit. So now we can just write that into a paragraph. The circuit shown above is connected with two 6-volt batteries and three resistors with the values shown. The currents I1, I2, I3 of each branch in the circuit are indicated. Using Kirchhoff's rules, write equations that can be used to solve for the current. So by Kirchhoff's rules, we know that I2 equals I1 plus I3, and we can rearrange that in different ways to solve. So we know I1 plus I3 minus I2 is 0, so we can just plug in values for them. So we get 6 minus 100 I3 minus 200 I2 equals 0, and 6 minus 150 I1 minus 200 I2 equals 0, and the third one would be 6 minus 150 I1 plus 100 I3 minus 6 equals 0. So now calculate the current in the 200 ohm resistor. So all we have to do is solve the system of equations for the first two. So we can rewrite them. So we just have to rewrite them and solve. So we get 6 equals 150 I3 plus 200 I1 plus I3. And we get 6 equals 100 I3 plus 200 I1 plus I3. And then we just solve for I1, and we get I1 is equal to 3 over 325, and that's approximately 0.00923 amps. And then we can plug I1 back into the equation to solve for I3. And you get I3 is approximately 0.0138 amps. And now we know that I2 equals I1 plus I3, so we can just add those two together and we get I2 is equal to 0.023 amps. Okay, now calculate the power dissipated by the 200 ohm resistor. So we know power is equal to I squared R, and we know we just solved for I, and we know that R is equal to 200 ohms, and I is 0.023 amps. So we could just plug that into the equation. You get 0.023 squared times 200. And then we get power is equal to 0.107 watts. So now the two 6-volt batteries are replaced with a battery of voltage E and a resistor of resistance 50 ohms as shown above. The voltmeter V shows the voltage across the 200 resistor is 4.4 volts. Calculate the current through the 90 ohm resistor. So I know the resistance is just 100 ohms plus 50 ohms, and that would be 150 ohms. And we know that current is equal to voltage over resistance. So we just divide 4.4 volts over the resistance, which is 150 ohms. And we get the current through the 50 ohm resistor is equal to 0.029 amps. Now it says calculate the voltage of the battery. So to find voltage, we need current, the total current and the total resistance, and that's Ohm's law. So we know that the total current would just be 0.029 amps plus whatever the current is on the left side, and that would just be 4.4 volts over 200 ohms. So we get the total current to be 0.051 amps. Now to find the total resistance, we know one part of the resistance would be 150 ohms, and the other part is a parallel circuit. So we know that 1 over RT equals 1 over R1 plus 1 over R2. So if we take 1 over the total, we get the total resistance of that part. So we get 1 over 200 ohms plus 1 over 150 ohms. And then you put 1 all over that, and we get total resistance is 236 ohms. Now we just plug IT and RT into the equation for voltage, and it's just 0.051 amps times 236 ohms. And we get the voltage of the battery is equal to 12.0 volts. That's all for this video. Hopefully now you know how to do some of the problems for DC circuits.